Alright, so for this problem we're trying to find the outer diameter of the spacers, and that's going to be these washers here. So ideally what we would do is we would use the formula for the stress of the spacers, which is equal to the force through the spacers over the area of the spacers. So we have the stress through the spacers, we do not have the force through the spacers, and we do not have the area of the spacers because we do not have the outer diameter of the spacers. So instead what we have to do is we have to start off by doing an analysis for the bolts and then use that for our analysis of the spacers. So we're going to use the formula: the stress in the bolt is equal to the force through the bolt over the area in the bolt. And what we're looking for here is the force through the bolt, because the force through the bolt and the spacer will be the same. So if we find the force through the bolt, we can use that in our analysis of the spacer. So we can go ahead and rearrange this formula and get that the force through the bolt is equal to the stress in the bolt times the cross-sectional area of the bolt. And our formula for the cross-sectional area of the bolt, here's our bolt, just a quick sketch. The area of the bolt is equal to pi times the diameter of the bolt, 0.016 meters squared over 4. And that's going to be equal to 201.1 times 10 to the negative 6 meters squared. And so now we can just go ahead and plug that into our formula above and solve for the force through the bolt. And we are given our normal stress in the problem. It says knowing that the average normal stress must not exceed 211 megapascals in the bolts. And I'm going to go ahead and convert the megapascals into pascal to keep everything in units of newtons and meters. So that's going to be 211 times 10 to the 6 pascals times 201.1 times 10 to the negative 6 meters squared. And we know that a pascal is equal to a newton per square meter. So we get that the force through the bolt is equal to 42,400 newtons. And so now we're going to do the same thing for the spacer, and we're going to go ahead and find the formula for the area of the spacer. So our spacer has an outer and an inner diameter, and we do not want to include the inner diameter, we just want to include the shaded portion. So our formula is going to be pi times the outer diameter squared minus the inner diameter squared over 4. And then we're going to go ahead and use this formula, which is that the stress through the spacer is equal to the force in the spacer over the area of the spacer. And we can rearrange this to get area by itself on one side, which I'm going to go ahead and do, and plug in the formula for area. Pi over 4 outer diameter squared minus the inner diameter squared is equal to P over the stress through the spacer. So the force P is what we just found up here, 42,400 newtons, and the stress through the spacer is given to us in the problem. It says knowing that the average normal stress must not exceed 149 megapascals in the spacers. So I'm going to go ahead and plug these two in. So we have 42,400 newtons, and then I'm going to convert from megapascals into pascals, and that's going to be 149 times 10 to the 6th pascals. And then we're just going to go ahead and have to do some math, which I'm not going to show. I'm going to go ahead and skip a couple steps and go to the outer diameter squared is equal to 6.19 times 10 to the negative 4 meters squared. And that's going to give us that our outer diameter is equal to 0.02487 meters, and they want our answer in millimeters, so that's going to be equal to 24.9 millimeters. So that's our final answer, and that's all for this problem.